This is a solutions video for Math for Liberal Arts, chapters 8, 9, and 10, spring 2012. And I gave the compound interest or compounding formula, the doubling formula, the half-time formula, which is pretty much what you needed for this test. And I just wrote that right here. Here's the compounding formula, and it tells us that it compounds at 0.5% per year, and we want to find out the growth. Well, what's the population going to be in 2050? And we know that in 2000 it was 100,000 people. So P is what we start with. So we start with 100,000, and then 1 plus R, which is 0.005, because that's 0.5%, and then to the 50th. So we're going to have 128,323 people in the year 2050 at this rate. Number 2, you could just estimate the doubling time, and we use the rule of 70. So we just took 70 divided by 6 and got 11.7. So in 11.7 months, it'll double from 100 to 200. And then the second part is a little more complex. How long will it take for the population of rats to become 1,600? So if we use the same formula we had before, the final is 1,600, the initial is 100, and the rate is 6%. We have to solve for t. So the first step we do is divide by 100, which gives us 16. And since we have this variable in the exponent here, we're going to take the log of both sides. Remember, the log rule says now we can bring that t in front. So we have the log of 16 equals t log of 1.06, and then divide both sides by the log of 1.06, which cancels this. And those would cancel then. Bam, bam. So t equals 47.58. So about 48 months it'll take to go from 100 to 1,600 rats. And then on number 3, if a house is appreciating 28% per year for 3 years, so it's a $201,000 house times 1 plus 0.28, which is the rate it's increasing to the third, the house will be worth $422,441.91 within 3 years. Number 4, inflation is going at 3%. Something's $100 today. What's it going to cost in 4 years? So 100 is what we have now, 1 plus 0.03, which is our growth rate, and then 4 is how many years. So it's going to cost $112.55 for that same item 4 years later. Number 5, there's the half-life formula. So instead of the base being 1 plus R, it's just 1/2, because we're using factors of a half. And we're going to start with P, which is just whatever it is. I'm just going to use 1, like 100% of what we start with is just 1. The time is 8,000 years, but the half-life is 2,000. So that's where the H goes, 2,000. So really we're going to have 4 half-lives. So it's going to have 4 times, which is really 1/2 to the 4th power, or 16th. So there should be about 0.0625 or 6.25% of the substance left, or 16th. On 6, same one. Microchips are 74 today. They're depreciating, so this is a minus sign instead of a plus sign. So we're going to take away the 10% for 2 years, which is really 0.9 squared times 74. So that microchip will cost a little under $60 here after 2 years. And then how long will it take before it's less than $50? Well, then you take, 50 is the end result. We're starting at 74 and the same, I guess it'd be decay rate, which is 10% per year. Divided by 74, take the log of both sides like that other one we did, and then we put the t in front and divide by log 0.9 on both sides, and so t is going to be about 3.72 years, or about, and I accepted 4 years as an answer as well. 7, the slope is just the number in front of the x, that's -1. The y-intercept is 2, and then a little graph. So there's the y-intercept of 2, and it goes down 1 over 1, down 1 over 1. So that's a -1 slope. Number 8, you drive on a highway at 57 miles an hour for 2.5 hours. So just distance equals rate times time. Multiply them, you go 142.5 miles. If you do it for 6.6 hours, you're going to go 376.2. And describe how one variable will respect the other. It means the longer you drive, the farther you go, or you can even mention it being at a constant rate of 57 miles an hour. But pretty much I'm just trying to get you to figure out that you'll go farther the longer you drive. And then for this part, they want the domain. The domain is this x values here, the size of the truck, which I just guessed the low end to be 2,000 to 20, 2 tons. Maybe that could even be 1 ton. 1 to 20 tons, or maybe it's 2,000 to 20,000 pounds, however big the trucks get. And then the mileage I put in the low end is 5 miles per gallon up to 30 for trucks. So, and if you look here, the mileage goes down the bigger the vehicle. So as weight goes up, the mileage goes down. And it's probably not linear, kind of like this. And on this one, describe with in words describe the function. That's like essentially if the longer I drive, the farther I go, almost the same thing. The slope is rise over run. So this one it looks like it goes up 40 over 2, which is really 40 over 2, which is 20. So 20 miles per hour, or 20 miles per hour is our slope. That's the rate at which the vehicle's moving. And they're constantly driving at 20 miles per hour. That's why it's linear. And it says when is it realistic from, well, 0. You can't have less than 0 time driving up to however long they drive. 11, this function says as the years are progressing, so is life expectancy. So just as the years go on, people are living longer. On 12, which is going to grow faster? A population growing at 4%, or if it's going to be double. So if one's growing at 4%, other one's at 2%, the question is it growing, will have grown by twice as many people than if it would have been 2%. Well, if you compound on 4% versus compounding on 2%, one curve will look like this, the other one will look like this. So the 4% is going to grow much faster. And if you take the approximate doubling time, if you take 70 divided by 4 and 70 divided by 2, that's going to be pretty close. But remember, if I get interest off my interest, then the 4% is gonna go faster because it gets to compound upon itself more often. So that's why that interest rate becomes pretty important. So the 4% will grow more than double than the 2%. It'll go faster because it's compounding upon itself. And on 13, it says two triangles are similar and if they have the same size but not necessarily the same shape. It's kind of a bad question. If two triangles have exactly the same size, that means all three sides are the same length, then they have to be the same shape. They have to be congruent. So in this one I accepted true or false. I accepted both. But really, if they have the same shape, then or the same size, they have to have the same shape, so they have to be similar. Since similar means just same shape, congruent also have the same shape and same size. So it actually fits both of those categories. 14, slope of a 5, so it's just rise over run, 5 over 14, so it's A. 15, find the area, which is pi r squared, this is the area of a circle. We're going to have stained glass up here, but we have half a circle, so we just take half of that and then take it times the cost per square inch. So it's $712.15. And then remember the radius is just half of 36, so it's 18. And the last one, if the length of an object is quadrupled, that means it's 4 times bigger. What would be the area? So if we think of it as length, if I make it, if this is the original, and then this is 4 times, this whole thing here is 4 times as big, then that's actually going to be 16 times bigger than this little thing right here. And if you take a volume and make it 3 dimensions, so it's quadruple the length, quadruple the width, quadruple the depth. That's going to be 4 times 4 times 4, which is going to be 64 times bigger than this little box right here. And that's it. So there was 50 points possible on this one, and I added a few more points. It was really about 45 points, but I just made it out of 50, which gave us a little bit of a curve. But there was enough good scores, and that was about it.